This set of notes is on addition and subtraction of rational expressions. The objective is just that, to add and subtract rational expressions. Remember that a rational expression is a ratio of two polynomials. Therefore, we will be applying what we already know about polynomials and fractions. Because we will be adding and subtracting rational expressions, we will be specifically looking at least common denominators. Remember that when we add or subtract fractions, we must have a common denominator. You should be familiar with this process already. For example, if we were asked to subtract 7/8 from 5/6, we would need to find a common denominator, which would be 24. 5/6 is equivalent to 20 24ths, and 7/8 is equivalent to 21 24ths. Once we complete the subtraction, we have a result of -1 24ths. Now, let's look at fractions in which the denominators contain variables. When finding the least common multiple of variable expressions, look at the numerical portion first. Then take each variable to the highest exponent. Our example here is 5x over 6wv minus 7z over 8w squared. In order to subtract these rational expressions, we must find the common denominator first. The least common multiple of 6wv and 8w squared is 24w squared v. In making equivalent fractions with this new denominator, we must multiply 5x over 6wv by 4w over 4w, because 6wv times 4w equals 24w squared v. And we must multiply 7z over 8w squared by 3v over 3v, because 8w squared times 3v equals 24w squared v. This results in equivalent fractions of 20wx over 24w squared v and 21zv over 24w squared v. Now that we have equivalent fractions with the same denominators, we can rewrite the fractions with a single denominator, giving us 20wx minus 21zv all over 24w squared v. Consider the binomial 5 minus 6y over 6 minus the binomial 7 minus 4y over 8. The denominators 6 and 8 have a least common multiple of 24. 6 times 4 is 24, so the first fraction needs to be multiplied by 4 over 4. 8 times 3 is 24, so the second fraction needs to be multiplied by 3 over 3. Be careful to realize that you are multiplying 4 by the binomial 5 minus y and 3 by the binomial 7 minus 4y. This means we're going to have to distribute. This results in the binomial 20 minus 24y over 24 minus 21 minus 12y over 24. Now, the point at which we write this as a single fraction with a denominator of 24, we must be careful of our signs. Because 21 minus 12y is being subtracted, you have to be sure to subtract the entire binomial. So it becomes 21 plus 12y. The signs change to their opposites. We now have the polynomial 20 minus 24y minus 21 plus 12y. Notice that we have like terms in the numerator. we need to combine them. 20 and negative 21 combine to give us a negative 1, and negative 24y plus 12y combine to give us negative 12y. The final answer is negative 12 minus 1 over 24. This problem asks us to subtract 3x over 6c to the 4th power v minus vy to the 4th power over 12c cubed d cubed. The least common multiple of 6 and 12 is 12, and remember you take each variable to the highest exponent, which gives us c to the 4th power, d cubed, and v. Therefore, our common denominators will be 12 c to the 4th power, d cubed, v. Let's figure out what each fraction needs to be multiplied by to make the equivalent fractions. 3x over 6c to the 4th power v needs to be multiplied by 2d cubed over 2d cubed. Remember, you must multiply the numerator and denominator by the same quantity. Vy to the 4th power over 12c cubed d cubed needs to be multiplied by cv over cv. The resulting numerators are 6d cubed x and c v squared y to the 4th power. Now that we have equivalent fractions, we can rewrite them with a single denominator. The final result is 6d cubed x minus c v squared y to the 4th all over 12 c to the 4th power d cubed v. In this question, we have denominators of 5x and 6y. The least common multiple of 5 and 6 is 30. Then we take each variable to the highest exponent, so we end up with 30xy. In order to get from 5x to 30xy, we need to multiply by 6y. So we also need to multiply the numerator, x minus 6, by 6y. Remember to distribute the 6y to the binomial x minus y. This gives us an equivalent first fraction of 6xy minus 6y squared. In order for us to get from 6y to 30xy, we need to multiply by 5x. Don't forget to distribute the 5x to the binomial 5x minus 6y. This gives us an equivalent second fraction of 25x squared minus 30xy. Now that we have equivalent fractions with a common denominator, we can rewrite them over a single denominator, giving us 6xy minus 6y squared plus 25x squared minus 30xy all over 30xy. There are like terms in this numerator. We can combine 6xy and negative 30xy. When we combine these like terms, they result in negative 24xy, and then we still have minus 6y squared plus 25x squared, and this is all over 30xy, and that gives us our final answer. This is the last practice question we're going to do. In this one, we have denominators of 5b cubed d and 15b to the 4th power c. Look at the numerical factors 5 and 15, and the least common multiple is 15. Now, take each variable to the highest exponent, giving us b to the 4th power dc. So our common denominator is 15 b to the 4th power dc. In order to get from 5b cubed d to 15b to the 4th power dc, we need to multiply by 3bc. So we're also going to multiply 8v by 3bc, and this gives us 24bcv. 15b to the 4th power c needs to get multiplied by d. So we also need to multiply the numerator by d. Remember to distribute the d to the entire binomial v minus 1, and we get dv minus d. Now that we have equivalent fractions and a common denominator, we can rewrite them over a single common denominator, 15b to the 4th dc. Our numerator ends up being 24bcv plus dv minus d. There are no like terms in this case, so that is our final answer. In conclusion, remember that when adding and subtracting rational expressions, you must have a common denominator. You can find the least common denominator by finding the least common multiple of the numerical portion and then use each variable to the highest exponent.